Hi students, so we completed haloalkanes and haloarene chapter 30 conversion question. Now we can move to the next organic chapter, that is alcohol, phenols and ethers, where we are going to study again 30 questions. Ready? So question number 31 for you, a direct question, cumene to phenol. Cumene to phenol, you studied around 4 preparation of phenol in your chapter alcohol, phenols, ether. What is cumene? You may know what is cumene. Cumene is what? Isopropyl benzene. There is an isopropyl ring, right? There is an isopropyl chain which is present on a benzene ring. This is called a cumene, isopropyl benzene. First to cumene, we will add oxygen. So we will place this oxygen in between this carbon and hydrogen. We get a compound, benzene with the CH3, OOH. How many of you remember the name of this compound? This is called cumene hydroperoxide. And this on acid hydrolysis, H3O plus, we will get which one? Phenol plus. Hope you remember the byproduct. What is the byproduct, my dear? Byproduct is acetone, right? CH3COCH3, byproduct is acetone. That not required here actually. Questions to convert cumene to phenol, so we can write to up to this one. So cumene when react with oxygen, you will get cumene hydroperoxide. Then on acid hydrolysis, it give you phenol. Question number 32 for you. Chlorobenzene to phenol, again a direct question we studied already in the haloalkane, haloarene part. Chlorobenzene to phenol is called Dawes process, right? Dawes process. What we treated first with aqueous NaOH at 623 Kelvin and 300 atm pressure. What you get, my dear? Sodium phenoxide, ONA. Sodium phenoxide, that's on treated with acid HCl, NaCl out, we get phenol. So chlorobenzene to phenol, what you call? Dawes process, don't forget, okay? Question number 33, 1-phenyl ethene to 1-phenyl ethanol. What is that compound actually? 1-phenyl ethene to 1-phenyl ethanol means here this is the compound. Okay, number 1-phenyl ethene to 1-phenyl ethanol. What is this reaction? Simple, right, my dear? Add what? H2O. Add H2O, that is follow Markovnikov rule, right? So take your compound, CH double bond CH2. We need to get one OH here, one H here. Just add water in presence of what? Acid. What is it called? Acid catalyzed hydration, right? Acid catalyzed hydration. You know, H2O contain which all ion? H plus and OH minus is there. Markovnikov's rule. Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. You will get the compound directly 1-phenyl ethanol. Ready, my dear? Yeah, ready. So keep practicing, okay? Practice the way which I am discussing here. Please practice the question again and again. So 1-phenyl ethanol to 1-phenyl ethene to 1-phenyl ethanol. Check what is the change in between. We need to get an OH here, one H here. So add water, Markovnikov's rule. Next one, ethyl magnesium chloride. Ethyl, what is ethyl magnesium chloride to propanol? Dear all, it's a Grignard reagent, right? Ethyl magnesium chloride is a Grignard reagent. From Grignard reagent, how we prepare a primary alcohol? We studied any Grignard reagent if you treated with a methanol. What is that methanol? Methanol is HCHO. Methanol, it will give you a primary alcohol. Grignard reagent when react with the methanol, you will get primary alcohol. Grignard reagent react with the other aldehydes, you will get secondary alcohol. Grignard reagent when react with any ketone, it will give you tertiary alcohol. Let's prove that. You know, Grignard reagent Mg plus, this alkyl minus. So the alkyl part will attack on this carbon, O become O minus, to the O minus MgCl will attack. So I am writing from here, CH3, CH2, it's attacking here. What is this actually? CH2, right? CH2, the O become O minus, to the O minus, the MgCl will attack, and we will add acid hydrolysis. We will do acid hydrolysis, right? What is H2O contain ion? H plus and OH minus. So H plus go to this oxygen, OH go to this side. Then you will get CH3, CH2, CH2, OH, C propanol. Remember all, Grignard reagent, if you want to convert into primary alcohol, what is a reagent? Methanol. Okay, methanol. Next one, methyl magnesium bromide. Again, methyl magnesium bromide. I think previous case is ethyl, right? Okay. This is methyl magnesium bromide to 2-methyl propan-2-ol. Dear all, 2-methyl propan-2-ol is a tertiary. Tertiary alcohol, if you want to get from a Grignard reagent, use a ketone. So, I'm using the ketone propanone because prop is enough, right? Propanone. Propanone. What happened? What happened? Okay, show the mechanism. Grignard reagent Mg plus the alkyl minus. Alkyl will attack on the carbon. O become O minus. To the O minus MgBr attack. So you have CH3, CCH3. Here one new CH3 attack. It become O minus, to which will attack MgBr. Ready? Now we are treating acid and water. Acid hydrolysis. From H2O, H plus come to this side, OH come to this side. What do you get? CH3, CCH3, CH3, then OH. All of you check the name. 2-methyl propan-2-ol. Yes, 2-methyl propan-2-ol. Remember, if you want to get a tertiary alcohol from a Grignard reagent, we should treat with a ketone. How to identify? Already one CH3 is there in Grignard reagent. Okay. The rest of all carbon should get from the ketone. So propanone. Like that you can decide the compound. Question number 36. 1-bromopropane. Okay, let me take the compound 1-bromopropane. Okay, 1-bromopropane to 1-propoxypropane. 1-propoxypropane is an ether, right? How to get ether? How to get ether from a haloalkane? Williamson ether synthesis. Williamson. What is Williamson ether synthesis? When a haloalkane react with the sodium alkoxide in dry ether, we get a ether, the propoxypropane, ethoxyethane, any ether can be prepared. So if you want propoxypropane, one prop already there in the haloalkane. So use the next one, NaOCH2CH2CH3. What it is called? Sodium propoxide. Sodium propoxide in dry ether medium. Dry ether medium. What happened, my dear? Simple reaction. The NaBr cut. NaBr cut, join the remaining. You get CH3, CH2, CH2, O, CH2, CH2, CH3. What it is called? Propoxypropane. So ether, if you want to prepare, we have to prefer which reaction? Williamson ether synthesis. Ready? Next one, bromomethane. What is bromomethane? CH3Br. Bromomethane to 2-methoxy-2-methylpropane. Again ether. Again ether. So we should know the compound structure first, my dear. What is 2-methoxy-2-methylpropane? You know, propane means how many carbon? 3 carbon. 2-methyl 2-methoxy. This is the compound. Okay. What is that? This is number 1, 2, 3. So 2-methoxy 2-methylpropane. Or you can call it a common name. What is that? Tert-butyl methyl ether. Tert-butyl methyl ether. See this CH3 already from this side. This CH3 already from the haloalkane. So rest of all parties from your sodium alkoxide. So what is that? NaOCCH3, CH3, CH3 and dry ether. What happened? This NaBr cut this alkyl and this alkoxy part join. You will get the ether. So in order to get ether, in this question and the previous question we used which reaction? Williamson ether synthesis. Don't forget. Bromoethane 2. Next question, bromoethane. Bromoethane to ethoxybenzene. Ethoxybenzene, that's also an ether, aromatic ether. So ethyl group is already there. What we have to use it? Bromoethane 2. What is ethoxybenzene formula? Benzene with O and C2H5 or CH3CH2. That's already here. That's already here, right? Okay. So CH2, CH3. This is what we call ethoxybenzene. So ethoxybenzene already there. From that, this ethyl group is, okay, it's already there. When rest of all part, this part from where, take the sodium phenoxide, ONA, and use dry ether. If you use, what is this compound called? Sodium phenoxide. So this NaBr cut, you will get phenoxide and the ethyl group. That is called ethoxybenzene. Again, Williamson ether synthesis. Next one, methoxybenzene. What is methoxybenzene? OCH3, right? Methoxybenzene, you know, it's also called anisole. Methoxybenzene, okay. Methoxybenzene to phenol and phenol to methoxybenzene, reverse also they ask you. So what is a simple reaction? Just what? Heated with HI. Just heat with HI. You know, hydrogen iodide contain H plus I minus. And this, how this break all of you? O minus and plus. Why O minus? Because you know, phenoxide ion is more stable. So to the phenoxide ion, the H will attack. You will get phenol, right? Phenol plus the CH3 will combine with the I, CH3I. You studied the ether bond breaking. So all of you, anisole, if you want to convert into phenol, just heat with which one? Hydrogen iodide, treated with the HI. Question number 40, benzyl ethyl ether. What is that? Benzyl. This is called the benzyl. Okay, benzyl. Next, ethyl. What is ethyl? CH2, CH3. Ethyl ether. Benzyl ethyl ether to ethanol. To ethanol. Same reaction. Heated, treated with the HI. Heated with the HI. What happened? Which bond break? I will break this bond. Why we are breaking this bond? If you break this bond or this bond, check the stability. If you break here, you will get O minus here and carbon plus. Always oxygen minus carbon plus, okay? If you, what is this carbocation, my dear? Benzyl carbocation. It is more stable due to resonance. Therefore, we break this bond. So to this positive, who will attack? This iodine will attack. So you will get benzene, benzyl with the iodine, benzyl iodide plus. What is right side you have? CH3, CH2 to the O and H will attack OH, ethanol. See, our product is which one? Ethanol. So ether bond breaking, one last part you studied, right? Very important, okay? So this is benzyl ethyl ether. When we react with the HI, this bond we need to break, not this one. Because it make more stability of the benzyl carbocation, and on the positive place the iodine and the negative place the H plus. Ready. Next one, anisole. What is anisole? Benzene with the OCH3. Anisole. How to convert? Para-methoxyanisole. This is anisole. What is meant by para-methoxy? One more OCH3 group. How we get the OCH3 group, methoxy anisole, and actually para-methoxy anisole is not the one, para-methyl, okay? Para-methyl is the compound, para-methyl, not methoxy, methyl. Mostly they will ask you methyl group on this one. Dear, if you want to get a methyl group on the para position, methyl is an alkyl group, right? So we have to do Friedel-Crafts alkylation. So Friedel-Crafts alkylation, what is the reagent? Actually, we are adding CH3Cl in presence of which catalyst? Anhydrous AlCl3 is the catalyst. So CH3 will come. You know where it comes? That decided by the OCH3. It is an ortho-para directing group. Remember all? Anisole is a ortho-para directing group. So the CH3 group will go to which one? Ortho and para. We need para, so that's enough. Okay, so if you want to get anisole to para-methyl anisole, directly do which one? Friedel-Crafts alkylation, where anisole is a ortho-para directing group, so the alkyl group can come to the para position. Next one, phenol to salicylic acid. I hope you get the reaction immediately. Phenol to salicylic acid is called Kolb's reaction. What is Kolb's reaction, my dear? Take phenol first. Phenol first treated with which one? Aqueous NaOH. It becomes sodium phenoxide, ONA. Then we will first treat with the carbon dioxide. Second treated with the acid. We get salicylic acid. What is salicylic acid? OH and COOH. Right. This reaction what you call Kolb's reaction. Phenol to sodium phenoxide. then to salicylic acid. And you have one more reaction, convert phenol to salicyl aldehyde. That is our Reamer-Tiemann reaction. What is Reamer-Tiemann reaction? Phenol, take it. First treated with what? Same aqueous NaOH, but along with what? Chloroform, CHCl3. When you add chloroform, what do you get? This becomes sodium phenoxide and it becomes CHCl2, right? Yes. You will get an intermediate, and then first we will treat it with the NaOH, it become ONA, and ONA already there, and react with which one? H plus, we get salicyl aldehyde. That is what? That is what? OH and CHO. Salicylic acid is OH and COOH. Salicyl aldehyde is OH and CHO. This is called Reamer-Tiemann reaction. Question number 44. Propan-2-ol, a simple reaction. Propan-2-ol to acetone. What is acetone? Propan-2-on. Propanon. Propanon is also called what? Acetone. Dear, it's a secondary alcohol. You know, secondary alcohol on dash, you get a ketone, oxidation. What is oxidizing agent? The anhydrous CrO3, copper at 573, right? Anyone you can use it. Anhydrous CrO3. Secondary alcohol on oxidation, you get ketone. Ketone on reduction, you get secondary alcohol. Don't forget. Tert-butyl alcohol. What is tert-butyl? What is tert-butyl? This is what? Tert-butyl with a alcohol. Tert-butyl alcohol to 2-methyl-prop-1-ene. 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 Dear all, alcohol, how it become alkene? Dehydration. Alcohol, how it become alkene? Dehydration. What is dehydration? OH and one of the H, you can take it and put a double bond here. That is its product. Okay, alcohol on dehydration, you get a alkene. But what is a reagent? You may study primary alcohol. If you want to dehydrate, we have to use concentrated H2SO4 at 443 Kelvin. Secondary alcohol, if you want to dehydrate, 85% H3PO4 at 440 Kelvin. But this is a tertiary alcohol. For tertiary alcohol, we are using only 20% H3PO4 at a temperature of 358 Kelvin. Don't forget. So alcohol on dehydration, we get alkene. That next one, ethanol. What is ethanol? CH3, CH2OH. Ethanol to ethanol. Simple reaction. Dear, it's a primary alcohol. Primary alcohol on oxidation, you get aldehyde. Secondary alcohol on oxidation, you get ketone. Which is the best reagent to convert a primary alcohol to aldehyde? That is PCC. That is your pyridinium chlorochromate. Or we can use anhydrous CrO3 or copper at 573. But best is what? Primary alcohol to aldehyde, PCC. Next, acetone. What is acetone? CH3COCH3. Acetone, how you can convert it into propene. Propene. See all, directly ketone, we cannot convert it into alkene. We can reduce first one. So ketone on reduction, what is the reducing agent? NaBH4, LiALH4 and all. Ketone becomes secondary alcohol. Ketone become secondary alcohol. Secondary alcohol. Alcohol on dehydration, we get alkene. So what is the reagent? Secondary alcohol. Secondary alcohol, we are using 85% H3PO4 at 440 Kelvin. OH and H cut will get propene. So dear, how to check this one? Ketone to alkene, directly it is not possible, but ketone we can convert it to alcohol first. Alcohol on dehydration, we get alkene. Ready? 48. Formaldehyde. What is formaldehyde? HCHO. Methanol. To N-butane. To N-butane. So many carbon we need to get extra, right? Methanol, formaldehyde contain only 1 carbon. Your product contain 4 carbon. Many methods we can choose it. Okay, let me do. We need to get 3 more carbon extra, right? Okay, let me take a Grignard reagent. CH3, CH2, CH2, MgBr. Okay, MgBr. We already studied Grignard reagent when react with the methanol, always we get primary alcohol because this negative will attack on this carbon, O become O minus, to the O minus MgBr will attack. So I'm writing here CH3, CH2, CH2, and the CH2 where it attack on the CH2, right? CH2, on the CH2 what you have? O minus, to the O minus who will attack? MgBr will attack. This on hydrolysis. This on hydrolysis, what happened? You know, from water, H plus go to this side, OH go to this side, you get CH3, CH2, 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 OH. You get butanol. Yes or no? You get butanol. So butanol is ready, but we need to convert into which one? Butane. Butane. So, but butane, if you made it, how to convert butanol to butane? Butanol to butane, method is there. Dear all, it's a primary alcohol, right? Primary alcohol on oxidation. For example, PCC, what will give you? It will give you butanol. Yes or no? Butanol on oxidation, you get butanol. You know, aldehyde, how to convert into a hydrocarbon. We studied Williamson reduction and Wolff-Kishner reduction. What is Williamson reduction? Treat with a zinc amalgam and HCl. The aldehyde part becomes hydrocarbon. That becomes CH3, CH2, CH2, CH3. We know aldehydes and ketone when react with the zinc amalgam and HCl, it's called the Williamson reduction. They become their corresponding hydrocarbon. Now it is ready, N-butane. Practice, okay, practice the same question again, practice it. This is the maximum question you can expect, same type. Ethyl iodide, what is ethyl iodide? CH3, CH2I. Ethyl iodide to diethyl ether. You know what is diethyl ether? CH3, CH2, CH2, CH3. This is called diethyl in between a ether. How to what reaction can be? Ether can be prepared by Williamson. So what is the reagent? NaOCH2CH3, sodium ethoxide in dry ether. In dry ether medium. This NaI cut, you'll get ethoxyethane or diethyl ether. Phenol to benzoquinone. You know, it's a direct reaction. What? Phenol to benzoquinone. How many of you remember the structure of benzoquinone? Yes, it's double bond and two ketone. Benzoquinone. Phenol to benzoquinone. One reagent is there. How many of you remember? Come on, my dear. How many of you remember? Na2Cr2O7 along with what? H2SO4 sulfuric acid. Na2Cr2O7. What do you call? Sodium dichromate, right? Sodium dichromate. Benzene. Phenol. What is this? It's an oxidizing agent. Phenol on oxidation we get benzoquinone. Phenol to benzene, simple reaction. How to convert phenol to benzene? From 11th grade you are studying this one. Just treated with which one? Zinc dust and heat. When you use zinc dust, the Zn take this oxygen, so they will go as Zn. Oh, it's a reducing agent. So phenol, when treated with a zinc dust, we get benzene. Now phenol to anisole. Anisole to phenol we studied before. Now it is what? Phenol to anisole. How it is? First treated with the aqueous NaOH. You know, phenol when treated with the aqueous NaOH, you get sodium phenoxide. Sodium phenoxide when treated with the methyl iodide, methyl bromide and all, what happened? This NaI cut will get our anisole. Benzene with OCH3. Ready all? Do you remember how we converted anisole to phenol? Just treated with HI, right? HI. Next, ethanoic acid. What is ethanoic acid? CH3COOH. Ethanoic acid to ethanol. Just one step. How will you convert a aldehyde directly to primary alcohol? Strong reduction. Strong reduction, right? You know, aldehyde majority mild reduction, you get aldehyde or ketone. Then again reduction, you get alcohol. If you want to convert acid directly to alcohol, we have to use strong reducing agent. What is a strong reducing agent? We are using LiAlH4. We can write one LiAlH4 second followed by hydrolysis. So basically, to convert carboxylic acid to directly primary alcohol, what is the reagent we are using? Strong reducing agent LiAlH4. Next, phenol 2. Phenol 2. Phenol, how you can convert it into which one? 2,4,6-tribromophenol. You know, bromination. Yes, my dear, bromination. What is the reagent we need to add? Bromine 3Br2 we need to add, right? 3Br2. That's actually what? Bromine water. Bromine water. You know, phenol is a very strong ortho-para directing group. Bromine water, when you add, all the bromine goes to ortho and para position. You know its color, right? It's white color, okay? White color. Similarly, how you convert phenol to picric acid? You know, phenol to picric acid, my dear. We are passing through most of the reaction. Phenol, when treated with a concentrated HNO3, you will get the picric acid. What is picric acid? 2,4,6-trinitrophenol, yellow color, right? Yes. Phenol on treated with the concentrated HNO3, we get picric acid. Butadiene, okay, what is butadiene? Concentrate on the reactions, okay. Butadiene to butan-2-ol, butadiene to butan-2-ol, okay. So basically we need to get one OH group on the middle carbon. We can do just simple. For suppose let me add HBr. Since it is symmetrical alkene, no need of Markovnikov's rule and all. So Br add to one carbon, H plus add to other carbon. We get CH3, CH2, CH, Br and then CH3. Now how you remove this Br by OH? We can use aqueous KOH. We have our haloalkane reaction. So we get butan-2-ol. Right? We will get butan-2-ol. Simple, right? To get a alkene to alcohol, or we can use acid catalyzed hydration, but better reagent is what? HBr, then you will get bromine, then aqueous KOH, OH. So this is what? Butan-2-ol. Next, aniline to phenol. What is aniline to phenol? You know, aniline, first to do diazotization. Don't directly do our reactions like warm water and all, okay? First you do diazotization. What is diazotization? Aniline treated with Na, NO2 and HCl, sodium nitrite and HCl at 0 to 5 degrees Celsius. That becomes what? N2Cl, benzene diazonium chloride. Benzene diazonium chloride, when you treated with a warm water, you know water, what all ions are present? H plus and OH. This OH come to benzene, you get phenol. Can you say the byproduct, my dear? This H plus combined with the Cl, HCl, and this nitrogen gas come out. So if you want to convert aniline to phenol, first aniline diazotization, you get the salt. That's on warm water, you get phenol, right? Question number 58, salicylic acid. What is salicylic acid, my dear? That is acid is there, OH is there together. Salicylic acid to acetyl salicylic acid. How many of you remember this name? Maybe you may remember the other name, aspirin, the medicine aspirin, right? How you get phenol to aspirin treated with acetic anhydride. What is acetic anhydride? This is what acetic anhydride, right? In presence of H plus. What is acetic anhydride? CH3. Sometimes you know this acetic anhydride they give you in this format also, okay? Don't forget, you know that. So, word the reaction, esterification. Alcohol when react with the acetic anhydride, simple dear all, do one thing. Take this H from alcohol, take this part from the anhydride. So what is actually cut? CH3COOH cut. CH3COOH cut. What is left in the system? Benzene with acid is already there. What is left here? OCOCH3. OCOCH3. This is called the aspirin, or it's also called acetyl salicylic acid. Okay, acetyl. So salicylic acid when react with the acetic anhydride, we get which one? Aspirin. Aspirin is also known as acetyl salicylic acid. Next question, ethyl chloride. Ethyl chloride to butan-2-ol. Ethyl chloride to butan-2-ol. So we need to get a alcohol, secondary alcohol. Simple. Make this one into a Grignard reagent. Let me treat Mg and dry ether. You know Mg come this side. You will get CH3, CH2, Mg, Cl. We know Grignard reagent when react with the other aldehydes like except methanol, you get secondary alcohol. See already butanol total how many carbon? 4 carbon. Your Grignard reagent already 2 carbon is there. So 2 carbon contain aldehyde, we can choose it. What is 2 carbon contain aldehyde? All ethanol. Ethanol. Remember all, Grignard reagent when react with the other aldehydes except methanol, you get secondary alcohol. You know this Mg, this is minus, this minus will attack here and O become O minus. So it will be CH3, CH2, CH, on which one CH3 already there, the O become O minus and MgCl will attack. This on acid hydrolysis, add water in presence of H plus. From water, H plus go this side, OH go this side. Yes, you will get a compound butan 2-ol. Ready all? Ready all? Okay, so haloalkane, if you want to convert into alcohol, first to make it a Grignard reagent and use the suitable aldehyde. Last question, my dear, propene to propanol, a simple reaction we have. Propene, right? What is propene? Propene to propanol. Propene to propanol. Can you give me many methods we can apply? Either we can do one thing, you can add HBr in presence of peroxide, so bromine will come this side, then aqueous KOH, yes, you will get this one. And you studied the reaction in this chapter, hydroboration and then oxidation. Remember, only one reaction given in textbook, their example, propene to propanol. What is hydroboration? First treated with a diborane. What is diborane? B2H6, or you may study it as BH2 twice. Yes, all. First add a diborane, then what we get, what is the complete process called? Hydroboration, then oxidation. This is hydroboration. What is oxidation? The reagents are hydrogen peroxide and base, alkali, water. So propene, if you want to convert into propanol, we can use hydroboration and then oxidation procedure. Where you studied this one? First preparation. After acid catalyzed hydration, you can see hydroboration, the same example in textbook. So that's it all of you. Prepare well, keep practicing. Now 60 questions now we completed. 30 from haloalkane, 30 from alcohol. Wait for 30 questions from the chapter aldehydes, ketones and carboxylic acid.